Hey, my name's Jared, and I'm part of Lab Group 9 for Humanoid Robots for Spring 2017. Today I'm going to be showing a quick demo of our semester project, which was to implement a vocal interface that allows you to use natural language to interact with a robotic system running on ROS. Notably, we have a proof of concept here for a landmark resolver that we built, but what really is the central part of the project is the fact that the structure and the architecture behind it allows any node to pick up something like this quite easily. All they have to do is parse out what's now a standard verbal request message and tell API AI that handles our natural language processing from Google to what a command that references a specific action looks like, or sounds like, and if new entities are needed, like nouns, tools, things that the robot needs to be able to identify as objects. For example, one of ours is landmarks. They have to be able to parse out a sentence and understand what part of the sentence is the landmark, as you'll see here. So this uses a client-server model and it allows you to command separate robotic systems. As you can see, we have two completely separate simulations running here, just as you would two separate robots. So let's get started. Hey, fetch the man.
Fetch the man, at your service. What can I do?
Navigate to coordinates 3, 3.
Fetch the man says head your service. What can I do? Fetch the...
So we have some issues with the vocal resolution now, where they'll hear their own responses as requests. It's a work in progress.
Fetch the man says finished landmark navigation.
So it's a response. I'll say, hey, fetch the man.
Fetch the man, at your service. What can I do?
Remember that this is the hallway.
Fetch the man says thanks. I'll remember that this is hallway.
And now let's talk to, hey, Mrs. Baxter.
Mrs. Baxter, at your service. What can I do?
Go to the table. So you're moving now.
Mrs. Baxter says head your service. What can I do? Fetch the man, at your service, Mark.
So sometimes we're still working on the locking in our I/O locking, and so ideally we would want the system to lock when vocal responses are being played, but the MVP was really to get this functionality picked up, which we've been able to do. And also what's nice is that you don't necessarily need to query them individually. You can query them as a group. So you can say, calling all robots. Oh.
You are speaking to the following robots. Fetch the man, Mrs. Baxter.
Navigate to the start. So you can see them both move independently, and
Mrs. Baxter says head your service. What can I do?
so
Fetch the man, at your service. What can I do?
go to the hallway. Hey, fetch the man.
Fetch the man, at your service. What can I do?
Go to the hallway. And so, what
Mrs. Baxter says finished landmark navigation.
So now you can see that Fetch is headed to the hallway.
Fetch the man says finished landmark navigation.
That was the landmark that we set at the beginning.
Fetch the man says heading to Halwino. Fetch the man says finished landmark navigation.
And so you can see that you're able to query multiple robots, command them to do separate things, sometimes with the same command. And so if start were a different location, they would have both been able to go to their own unique location, and they can respond individually based on their own understandings of the environment, of their own environment. And so I think one of them has wall and one of them doesn't. And let's see what happens when we try and ask both of them to navigate there. Calling all robots.
You are speaking to the following robots. Fetch the man, Mrs. Baxter.
Go to the wall. Calling all robots.
You are speaking to the following robots. Fetch the man, Mrs. Baxter.
Navigate to the wall. So you can see that Fetch is now headed to his understanding of the wall, right there, which was previously set.
Mrs. Baxter says heading for service. What can I do? Fetch the master says I don't know where that is.
Yeah. So you can see that because Mrs. Baxter doesn't have that landmark, she was able to respond and say, "Hey, I don't know where that is," while Fetch was able to still go ahead and implement the action. So that's a look at what our project is, how it works, and what it's capable of. And with that, and hopefully a little bit more I/O work, you're able to command an arbitrary number of robotic systems in a lab using natural language and pick up your new functionalities that you build very quickly, and pick up natural language interfaces for them, and turn that into a trivial matter, creating that. So, hope you like it. If you have any questions, let us know. But yeah, thanks for checking it out.